All right, everybody. It brings me great pleasure to bring you the notes that we're going to be talking about today. Because I'll tell you what, half of my teaching career here, we had no idea what was going on Pluto. For the first 5 years, everything was just speculation. And nobody knew exactly what it looked like or what was going on, if it had an atmosphere, if it actually had ice or anything like that. But now we know so much more because in 2015, we flew there, took a lot of close-up pictures before the satellite sped away. So today we are going to focus our discussion on Pluto. Basically.
Oh, is that why you haven't planet?
Because it looks like a golf ball?
No, it's a golf ball. Yeah, is it just like a disco ball?
The picture you see before you is the best picture we had of Pluto before 2015. And it kind of does. It's just basically a... Yeah, right here.
No thing from Mickey or Disney World, that metal thing that's about its use.
Oh, sure. Basically what this is it's a conglomeration of a lot of different pictures taken from really, really far away of Pluto. This is the best image that we could have. In terms of the history, just say that, yeah, he does have clothes on for a change, huh?
Maybe that's why he does.
God of Darkness, right now named after the God of Darkness and the underworld. Maybe that's why it was demoted. You're wearing too many clothes, Pluto. So just the middle bullet point there. So of course Pluto got demoted in 2006. So you guys are what, 5 or something? 3? So you probably don't remember too much of when Pluto was a planet. But yeah, so the International Astronomical Union is the governing body responsible for demoting Pluto. So I just kind of thought, if you're going to demote somebody, you're really going to demote the God of Darkness. Doesn't sound like the smartest idea in the world. So these were the best images of Pluto as of 1994 and as of 2002 and 2003. So that's the best we could do.
Wait, how did it work? We go back. How did it work?
I don't know. Ouch. So what ended up happening is back in 2006, when I was in college, this was a big deal. They were making this big mission that was going to go and take a look at Pluto. This was when Pluto was still a planet. And so they launched it, and it wasn't until July 2015 that it actually ended up getting close enough to Pluto to take those really cool pictures. This is the spacecraft that flew by. You can see a size comparison compared with some of the folks working on it there. So it's a pretty big satellite dish equipped with cameras and other data collection instruments. And this is it being launched into the wild blue abyss. And what it wanted to do is map the surface of both Pluto and its moon Charon. I wanted to describe the geology of both, look at the atmosphere on both Pluto and Charon, surface temperatures, and see what else is going on. Maybe it has rings or something. So these were the best images we had of Pluto then, as it got closer. This is July 1st, 2015. So it's still, you can see, 9.2 million miles away, 8.3 million, 7.8 million. These were the best pictures we had of Pluto for about 2 weeks. This was 2 weeks before the close approach. And when we're talking about those images, this again was kind of the best image we had from when it was still that far away. And then there was great excitement and jubilation because everything worked according to plan. It's like the best birthday party ever, right? So when we finally did get our first look at Pluto, how many of you guys, listen up for a second, how many of you guys actually know what Pluto looks like and have seen an image? Maybe a couple? You will now see the image of Pluto as it began approaching. Bigger and bigger and bigger and brighter and brighter. And finally we got to that close approach. And this is what Pluto looks like. Yeah. So this is our first real good picture. Let's give a round of applause for everybody involved in that mission. All right. So we're going to talk about Pluto today. You can kind of see it's got like a little ice heart there. That's kind of interesting. This is the map of Pluto's surface. You can see the areas to the sides. These are not as well defined because the spacecraft was moving so quickly that it could only take pictures of one side of Pluto. By the time it turned again, it was far enough away that the pictures were kind of grainy. So that's your map. These are some unconventional locations here that you can see on the surface of Pluto. It does have coronary artery disease. If you're familiar with the Lion King, you've got the border of the Pride Lands here. You don't want to go beyond that. That's where hyena country is. You've got the debate hole where they're putting people who debate whether Pluto's a planet. That's where I'd be located because I'm still debating that. So yeah, you can take a look at some of those things there. Mega Man. Who would have thought there's a charging socket? Here's an up-close image of Pluto because the images that they took were not just from a distance. They were able to zoom in with very high-resolution cameras to certain locations of the planet. And this is the sort of thing we see. What you're looking at right now is actually nitrogen ice. And we'll take notes on this in a little bit, but it's exciting. You can see it kind of flowing over here. And nitrogen ice is much different from water ice. Water ice is very hard. Nitrogen ice would be something like really thick putty. That's how that would be. So you can kind of imagine it could flow because it's not as solid as water ice would be. Another image right there, and you can see it sort of flowing around the edges. And this is in that heart-shaped region that we talked about. The surface is terrestrial, it is icy, and it is rocky. You can see we've got some kind of interesting pitted material there. Surface features. Write down surface features. As mentioned, these are pits.
I don't like that.
Yep, write down pits for surface features. And this first part of your notes, you're going to be taking just some examples of surface features on Pluto here. It might. Might be too thin for us to see from this far away, though. So you got your pits there. And basically, if you were to actually be walking, these would be very big, like valleys. In addition to that, if you look real close, you can see these things jutting out of the surface. And you can see this kind of red stuff near them. This is material that was ejected from inside Pluto. These are cryovolcanoes. You'll write that down. And this brings up an interesting point that I'll mention later on, too. It was fully expected, and it was like, if you thought anything other than this, you're stupid. It was fully expected that when we got to Pluto, we'd find a cold, dead, inactive, just rocky world, and that's all it would be. And as you'll see as we go through and explore this planet, you'll see the exact opposite. We see a very vibrant, very interesting world. And this is a zoomed-in picture of those cryovolcanoes and the material that has come outside of them there. If we zoom into this part of Pluto, kind of the crease of the heart there, you can see we've got different sort of snow formations, different pieces of hills. And if you zoom in even closer, we've even got pits inside of those icy hills. And these would be like, if you see a big hill that you go over on the road or something, that's about the size of these pits. You'd be going down and up, and you'd be going down and up. Too small to be craters. These are areas of Pluto that were named just kind of arbitrarily, and we're going to zoom in on different locations to see what's going on in different spots. So the Tombaugh region is what they named this heart-shaped area after Clyde Tombaugh, who actually discovered Pluto. We'll see how he did that in a little while. But we've got a couple things here. If we zoom in on that heart-shaped area, we've got troughs and we've got hills. Go ahead and write down hills. That should be enough for that one. Yeah, these are still under surface features. Yep, just hills. And then we zoom out again. And again, if it seems like we're exploring kind of quickly, we sort of are, because we're going to talk about Charon in this exact same lesson today. Because back in the day, there was hardly enough information on Pluto or Charon to make one full day. Now we've got a lot to get through. But there's only so much you need to take notes on, so you won't be taking any more notes than usual. But hold on to your seats, because it's going to be an interesting ride today. If we go over here, Tartarus Dorsa, and we zoom in on this area, we can see that we have some interesting things going on here. These are also mountains, but they're not the type of mountains that we find everywhere on Pluto. These are actually mountains made of water ice. Go ahead and write down mountains. It's kind of interesting when you think of mountains like Mount Everest or the Rocky Mountains, you think of just those rocks that make them up. This is actually completely made up of water ice. So you could skate up and down. It would be a good time. In that same area, what we see here is we see kind of a scaly formation. I don't exactly know what I'd call this, but I just wanted to throw the picture in. Nice big zoomed in picture in that same location, that same area. Zooming back out now, let's take a look at this area down here. You can see we've got a sliver of like white stuff going upwards, and we want to see what that's all about. If we zoom in here, we've actually got some snow. Now this is not the snow that we're used to on Earth that's made up of water. This is methane snow. And if you remember the deal with methane when we were walking around on Titan, it stinks real bad. So you're going to want to make sure that you bring a mask if you play in the snow on these mountains. You don't have to write any of this down. I just wanted to identify that we do have some snow here on Pluto. And it's not just this one location either. There's snow elsewhere, but it's made up of something different. Looking here, this is kind of the bottom area of that heart-shaped region on Pluto. And if we zoom in here, you can see that we've got some mountains over there. But more importantly, we've got these icy plains. If you were walking on here, you could skate right across and be nice and flat. This is the last surface feature that you should write down. Now, I believe the next picture is actually the most zoomed-in picture that we have of Pluto, the highest resolution. It doesn't look real highly resolved because it's zoomed in so far. But if we zoom in on that area, you can see a close-up of these mountains, and you can see that ice coming right up against it. Pretty interesting right there. And you've got your little hills, and you've got your little troughs there as well. And basically what's happening when we see this ice here, I mentioned before it's nitrogen ice, and because it's not super solid, it can actually flow over periods of time through these mountains and up different valleys, and that's what you see occurring here. Zooming out again, let's take a look at this little area. This is just to the left of your heart area there. And if we zoom in on this location, you don't have to write this down, but these are kind of hard to find on Pluto, even though it was speculated that it would be a full, cratered planet. But it's not. It takes a lot of time before you can actually find craters on this world. And the reason for that is because it's a very young planet, and the surface is being resurfaced pretty frequently. So there aren't too many craters out there. Zooming out again, this is a false color image of Pluto, and what it's meant to show are some of the different atmospheric elements on the planet. What I'd like you to write down here, write down surface/atmosphere. Surface/atmosphere. And then after that, just list these three things: methane, nitrogen, and carbon monoxide. And you can see from the picture where these different things are located here. The methane is pretty well spread out over the planet. The nitrogen is isolated mostly to the heart and the northern region. And carbon monoxide, if you need some of that, you got to go in the heart-shaped region. You have carbon monoxide in that location. It's not really anywhere else. You can see specks of it around, but most of it is confined to that one spot there. In terms of days and years on Pluto, anybody want to guess how long it takes for little old Pluto to go around the sun once? 300, 400, I heard 100 something. You're in the ballpark there. 248 Earth years to go around once. Yeah, you can skip this. I want to make sure we get through everything. So it spins on its axis in 6 Earth days. So you'd have a long day if you're on Pluto's surface. It does go around the sun every 250 years or so, so it takes quite a while. And for a little bit of that period of time, it's actually closer to the Earth and the sun than Neptune is. And that has some interesting effects on what we'll find as the atmosphere of Pluto. That'll come up a little bit later. 9th planet from the sun, just about 40 Earth to sun distances away, and it's going around the sun at about 3 miles per second. Now, Pluto, as it's orbiting, goes around in not exactly a perfect circle here. It's elongated quite a bit. This one's a bit exaggerated. It's not quite that elongated. That one's a little bit closer to reality there. So you can see for a period of time, it is closer to the sun than Neptune is. And I think it was 1999 was right here. So right now it's probably right about there in that location. Well, they can't because Pluto is angled a little bit, so it never actually crosses the spot where Neptune goes. Another example right there. In terms of size, write down Pluto's diameter. A little bit smaller than the Earth's moon. This is one of the other reasons that a lot of people just say it shouldn't be a planet. It's smaller than our own moon. And there's an argument to be made there. But talking about why Pluto is or isn't a planet is something that we'll focus on for an entire day, either this week or next week. I forget exactly when, but I will save that discussion for that day. So it's still pretty big, 1,470 miles across. Here is how big Pluto looks compared with the United States. This is Pluto's moon Charon. So it's still pretty big. You won't want to get hit by it. But you can skip this one. You could fit 155 Plutos into the Earth. 1.86 grams per centimeter cubed. This is a very, very low average density for a solid planet, which kind of makes it interesting to think about what might be existing below the surface of Pluto. As Pluto goes around the sun, it does so at an axis that's pretty bent over like that. It's not quite vertical like Uranus is, but it is at a very, very big angle. So it does have very pronounced seasons. And we'll talk more about those seasons in a little while. So 1990 was the last year it was really, really close to the sun. Daytime temperature, negative 360. You can write that one down.
Oh, I have a question.
Yeah.
So, stick your hand outside, like you're, let's say like in a house or something on Pluto.
Yep.
And you would like just stick your hand outside without the rest of your body feeling cold at all. Would your hand like freeze instantly?
Pretty much. Negative.
So you couldn't like put it out there and pull it back in and it'd be fine?
Well, I mean, if it's something like, you'd be okay. But
So
if you're like,
for like 3
if-
seconds, it would.
3 seconds, yeah, you're pushing it for 3 seconds.
Oh my god.
It's like, I mean, imagine putting your hand in your 400-degree oven for 3 seconds.
Yeah.
Yeah, I wouldn't give it a try. Probably no permanent damage, but it would hurt an awful lot. -3, well, they probably would have some permanent damage there. Yeah, yeah. Nighttime, -400, that should be an easy one to remember. Now, I picked this background for a reason. Believe it or not, it snows on Pluto. And we'll talk about why that happens in a little while. So, another thing you can write down about Pluto is it actually does have an atmosphere. It's thin, but it's there. So you've got an atmosphere on Pluto. You can write that down. What's that? Yep. Exactly. And this is a zoomed-in picture. As that spacecraft was behind Pluto and looking back, you can see the atmosphere as it was going past Pluto. And you can see this, three-dimensional world here. It's very active, very interesting. Pluto's a really, really neat place. So yeah, pretty good description here of what the sun would look like from this distance. Pluto's atmosphere is mostly made up of nitrogen, just like ours. Ours is mostly made up of nitrogen too, but Pluto's is sort of being blown away by the solar wind there. You can write this down. Now, the way the snow happens on Pluto is rather interesting. Pluto is obviously super cold, but when it gets closer to the sun, it gets to the point where the ice, that ice that was flowing on the surface is nitrogen ice, like I mentioned. If it gets warm enough, it can actually sublimate up and create that atmosphere. So what ends up happening then is when Pluto, like it is right now, going further away from the sun, that nitrogen ice that was in its atmosphere begins to freeze again and fall to the surface as snow. And so that's what's happening, and that's why we get snow on Pluto. The sun looks super, super tiny now.
It'll still hurt, right?
If you stared at it, it probably won't hurt your eyes, but it would be bright enough to cast shadows and everything. It would still be bright. It would still be very bright. Maybe it would hurt your eyes. I'm not sure. That's a good question. We can only see it at nighttime because we can't see it during the day, and we cannot see it without a telescope, unfortunately. It's way too far away, way too small to be seen, even under the best conditions. This guy was the first person to see it, though. This is Clyde Tombaugh, and I'm going to, with that telescope. This telescope is the same size as the one I have in the back of the room. No. So, the way that he did this is how you figured out when there was a new planet is you took photographs, different, several nights apart. You can see these are about a week apart. And he printed these photos. And what he noticed, if you look real close, you can see this little dot here.
How do you think that out?
Oh, right.
And over here, that little dot is gone. It is no longer there. It moved to that location. Because you see there's nothing over there in this picture.
And you can really spot Waldo.
No kidding. And so you can confirm this because, listen up a little bit, guys. A week later, it was further over and further over. And that's how you find planets. You see things in the sky that are not in the same location with respect to the background stars. All these stars are in the same spot at some point every night. So yeah, that's how he figured it out. If you do spot Pluto with a telescope, you're not going to be able to tell it's Pluto, because it's just going to look like a super faint star, even with the telescope like the one I have. And you can see it's really tough to tell it from the background unless you know exactly what you're looking at. If you look at it through the Hubble, this is the best picture you're going to get. In terms of what it looks like during the day and what it looks like during the night on Pluto, during the day we've got a blue sky thanks to its atmosphere. At night it's going to look black. Go ahead and write down that it is 6.3% of Earth's gravity. So if the question on the quiz would be, how heavy would you be on Pluto? If it's 6.3% of our gravity, you're going to weigh 6.3 pounds if you're 100 pounds on the Earth. If you feel like you need to write that down, feel free. But 6.3% of Earth's gravity means if you weigh 100 pounds here, you'll weigh 6 pounds there. A 100-pound person would weigh 6 pounds on Pluto. That's what you should make sure you know here. So this has an interesting, aside if you're talking about jump height. Because if you only weigh 6 pounds here compared with Earth, you're going to be able to jump a lot higher and a lot further. If you can jump 2 feet on Earth, you could jump 16 times your jump height here. In other words, 32 feet in the air. And that's the bottom of your foot that would be 32 feet in the air. Imagine this is like going outside beyond the cafeteria there and jumping to the roof of the school. That's what you'd be able to do on Pluto. All right. It is an active place geologically. You can skip that. Write this down, though. The crust is made up of frozen nitrogen. Yep, just the crust. I had you write down the atmosphere, right? Good. I wonder if that's going to be on the quiz. A few more things about Pluto before we jump into Charon. Again, the crust is frozen nitrogen, and pretty much everything on the surface is why it is because of nitrogen, whether it's ice or whether it's most of the mountain ranges that we find on the surface. Pluto, does it have a magnetic field? Any guesses? No, it doesn't. So that's too bad. Is there water on Pluto? Any guesses?
Yes.
Of course there is, as seen in this picture here.
Wait, I'm sorry. The crust, what was the crust?
Nitrogen.
Frozen nitrogen.
Frozen nitrogen, yeah. There is water ice on Pluto. You can see where it's located in this picture, but you don't have to write this information down. Of course, there's no water ice here because this is all nitrogen ice, as I mentioned before, in the big heart.
Why does that look like India?
I don't know. It's a good question. A couple other things. It's sort of interesting. Who would have thought that Pluto would be on Pluto?
Oh!
Of course, what happens? What happens if you land on Pluto? You would probably get bitten. Really rounding out the Pluto jokes here. Seriously, though, you'd be frozen solid. You don't have to write this down, but you should write down this slide here, why we know that Pluto is young. because this is such a recent, important find, we'll be watching a day or two of videos on this mission and what they came up with and some of the difficulties they had in the process. But what they expected to find is they expected to find a cold, dead, uninteresting, inactive world. They thought it would just be a big ice ball or a big rock ball with nothing else going on, because they thought Pluto is billions of years old. And if it is billions of years old, we should not find an atmosphere. It should all have already been stripped away by the solar wind. We should not have found mountains of ice. We should not have found a craterless plain. You should see craters everywhere. It should be an uninteresting, inactive world, but it turns out that it's the exact opposite. Pluto is a really, really cool place, and it's got all sorts of things going on, even more than Mercury, even more than a lot of the inner planets, even Mars. Pluto's got more going on in its surface than Mars does. And of course, we feel bad for Pluto, and I believe it should be a planet, but that's something we will get into later. This again was what happens when you go into the shadow of Pluto. This is that mission looking back and seeing the outline of the sun's rays going around. And because it's fuzzy, you can tell Pluto has its atmosphere there. Pluto comes in first place for a lot of things. You don't have to write any of this down, because it's a bit too much, I think. But it is the coldest place in the solar system. It is the smallest planet, furthest from the sun, most eccentric orbit, slowest orbital speed, and it gets first place for sportsmanship. So hopefully that makes up for the International Astronomical Unit demoting it. More on Pluto later. For right now, though, nothing for second place, but that's okay. Pluto comes in first place for more things than any other planet. Go Pluto! All right, on to its moon, Charon. And you can pronounce Charon in a couple different ways. Charon or Charon is just fine. This was the picture. That was the best image that we have of Charon as of 2015, before we actually got there. So, moon of Pluto, Charon. Write that down. And the good part about the mythology, again, is, when we have planets, the moons tend to be named after, mythologically, something that's similar. And Charon is no different here. Pluto is the god of darkness and the underworld. So Charon is... I'm going to have to click here. Charon is the boatman who ferries the dead to the underworld. So you'll want to write this down. Look at this. He's wearing even more clothes than Pluto. We're headed in the right direction.
Wait, then what is the sun?
We'll get to that later. The sun isn't really named after a mythological person.
What is the word?
That's a good question. I'll consider that. But yeah, so Charon is that boatman who ferries the dead to the underworld. Looks like she's seen better days. But yeah, that's a dead person. This was the best image of Charon that we had until we actually got there to see it. And this image of Charon has morphed into a high-definition picture of this. So that's Charon. A couple bits of information about Charon before I let you go. That's its size. You don't have to write it down. It's still pretty big as far as moons go. About half the size of Pluto. Again, compared with the United States, Charon would be about this size right there. Kind of an interesting picture here. So this would be standing on Charon, looking at a solar eclipse that's occurring on Pluto. That would be an interesting sight. The surface is cratered and icy, but the most important thing about the surface, one of the most interesting things that we found, and what you should write down, is this. This little thing right here is a mountain, but it's coming up out of a very deep valley or a very deep moat. So we've got a mountain in a moat. Nobody knows how it got there or why it's there, but we've got a mountain coming out of a valley for some reason. Pretty much. That's probably why he had Venus go the wrong way, and why he had Uranus go the wrong way.
I can confuse all the smart people.
Like, oh, you think you know better than me? I don't think so. Mountain in a moat. So that's one of the most interesting things right there. Looks kind of like a tooth or something if you look at it right. A couple other things about Charon's surface. We've got the Super Grand Canyon there, so that's rather interesting. You don't have to write that one down, but it would be even bigger than the Grand Canyon on Earth. And when you consider how small Charon is in comparison, that would be a huge, huge surface feature. Looks like a big scar going down. In this location here, this is just an elevation chart. So you can see we've got elevations up to 7 miles high. So that's higher than Mount Everest. So Charon, this tiny little moon of Pluto, has mountains and it has ranges even larger than the biggest ones on Earth. Again, this is what people thought Pluto would look like when you're standing on Charon, a cold, dead, cratered, rocky world. But it doesn't look like that, of course. Here's the last thing I need you to write down. I'll give you some time here. Yeah. Sure, he's just finishing up his notes, but yeah, whenever he finishes, you can go ahead. Brady, when you're done taking notes, they'd like to talk with you. I do got a few more pictures I want to show you once you're done writing this down, but this is the last thing you need to write down. I'll switch the slide in about 15 seconds. If you don't get it all written down, feel free to check out the video. It'll be on Schoology. But I do want to get through a few more pictures. So yeah, these snow and water effects are different here compared with Pluto. Pluto, it's nitrogen. Here it's water and ice for these cryogeysers, and you get the same type of effects from cryovolcanoes. Images like this are pretty cool to look at there. That's the sort of thing you'd see. The sun looks pretty accurate too. You can't see Charon from Earth. This was the best image from Earth. From the Hubble, that's the best image we got. And over time, that picture changed when we saw both these worlds close up. Have a good day, folks. For those of you still listening at home, this is Pluto here, and that's Charon going around it. You can see that they kind of orbit each other in an interesting way there from their center of mass. It does look like a donut, doesn't it? So yeah, there's Charon. That's the best image that we had until our visit in 2015.
Looks like a disco Pluto.
It does. Good old it's a party on Pluto and Charon. That's what we get from this. But that's our final image. That's our family portrait of Pluto and Charon. Two amazingly cool worlds.
And Charon looks like the small bug of Pluto because of the colors a little bit. Like
Sure.
painting.
Yeah, I agree.
Have a nice day.
Thank you. You too, Logan. And you guys have a nice day too.